Hello students, this is your professor Dr. Sharma. In today's lecture series, I will be discussing about historical background and the working principle of Van de Graaff generator. Okay, so in last class you talk little bit about historical background of electricity and magnetism, how these two are interrelated to each other, why these two are the same kind of forces, they experience the same kind of forces, but uh, you can see in two different ways, but they are the same thing. And you know that how the equal charges, similar kind of charges repel to each other, and the opposite charges attract to each other. And you also knew that how static electricity can be created by using contact or by using electrostatic induction. That means without contact. So let's talk a little bit about the Van de Graaff generator today. So the generator actually very powerful generator to create the high voltage. Basically before very powerful hadron collider uh, was particle accelerator, powerful particle accelerator were created. So this kind of accelerator was used to accelerate the elementary particles like protons, uh, like helium ions, alpha particles, or neutrons. But nowadays we have the uh, very powerful accelerator in Brookhaven National Laboratory and the CERN. So there are many powerful accelerator. But now, what is the working principle for the Van de Graaff generator? This is the name after one of the American physicists, Robert J. Van de Graaff. For his honor, we call its name as the Van de Graaff generator. So basic principle of Van de Graaff generator is static electricity. Static electricity. So let me recap. In static electricity, you know that all atoms, all matters made up of atoms. And these atoms made up of electron, proton, and the neutrons. And electrons and quark are the elementary particles, and quark compositions makes the proton and neutron. Proton is positively charged and electron is negatively charged, right? And proton and the neutrons restrict to each other. They bind to each other with the very, very strong force we call the nuclear force. And the electrons are revolving around that. So because nucleus has the proton has the positive charge, electron has the negative charge, that's why electron always attracted toward the proton. That's why it revolves around the circular path, unless you apply some forces to take it out from that particular orbit. But the question you may ask, so many protons in the nucleus, so many neutrons in the nucleus, depending on the elements we are talking about, or the compound or matter we're talking about. Since the same charges repel to each other, for example, inside the nucleus, there are so many nucleons, right? So nucleons means the combination of the proton and neutron that makes the one nucleon. And if you combine all of the nucleons, that makes the nucleus. So inside the nucleus, there are a lot of protons. Protons have positive charges and similar charges repel to each other. Then why not protons are not escaped from each other? The answer is the very strong nuclear force experienced in the nucleus. So the repulsive force between the protons is smaller than the strong force, binding force between the protons and the neutrons. That's why protons are stick with neutrons and remain in the nucleus. But now, that's why it's always easy to remove the electron or add the electron. In particle accelerator, it's always, add or remove the electron. The neutron is easier because neutron is the neutral particle. Now, to understand the Van de Graaff generator, basically two important concepts are very important. The first principle is, first concept is, suppose you have a surface like that, and now it has a pointed surface. And if you charge this surface like this way, suppose you charge with positive charges, you remove the electrons, then excess positive charges will be remain there. And if you see like a pointed surface, then charge density will be higher. So we'll discuss about that, because the charge density sigma is always inversely proportional to the radius. So you can see here the radius here is smaller than the radius here. That's why smaller the radius, because the spikes or the pointed surface, the radius will be smaller. That's why higher number of charges remain there. That's why charge density is higher. First of all, to understand the Van de Graaff generator, you need to understand that. So in pointed surface, you have the charges, charge density is always higher in the sharp. Second concept, okay, the first concept is point surface, means pointed surface, we can say that. Let me write down. Or in sharp point, you can say that. In sharp point, in sharp surface, charge density always, right? Number second, the second thing is, let me take simple example. If you have a sphere, spherical cell, and it has, suppose, 3 positive charges here. You can take 3 negative charges remain here. Suppose the spherical cell A, and you want another spherical cell, bigger spherical cell called B. It has, suppose, 6 positive charges. If you want to remove all the positive charge from this spherical cell to this, what you can do is you place this smaller one inside the bigger one. Then what happens is these positive charges goes outside the spherical cell. So inside there are no charge. This is the inside the cell, there are no charges, and outside is positively charges. All of the charges, free charges, I am saying that the free charges goes outside the sphere. This is the characteristics, because this conductor, spherical cell conductor, wants to make the electric field zero. Why that happens, we'll discuss in our coming days. This is the another thing. Okay, so total charge of spherical sphere will go to the outer sphere, always in the outer sphere. So total charge, let me write down here. Total charge in the spherical cell go in the outer layer of the conductor. Outer surface, we can say that. Outer surface of the conductor. These are the 2 important things you need to understand to describe the Van de Graaff generator. Now, This is the diagram for the Graaff generator. So it has following components. So here you need the metal sphere, hollow metal sphere, and to make this stand on the ground, you have the insulating support here. You can see this is the insulating support, and inside this you connect the two pulley by the insulating belt. This is the insulating belt made by the nylon. You can use other material, but nylon is familiar to use here. So nylon belt, you have the two pulleys up and down, and you connect this lower pulley with the motor. That's why we call motor driven pulley. And you use the two combs or two brushes. The first comb we call C1, and second comb, second brush, you can C2. And these combs are metallic comb. You know the metal is the good conductor for electricity, right? Good electrical conductor. Now the first comb, the lower comb, which is nearby the motor driven pulley, is connected to the external sources or the batteries so that you can provide the charge, right? Initially the comb is electrically neutral. You know the all matters generally electrically neutral unless you apply some charges to disbalance the amount of charges, whether you remove or add the charges on it. So what is happening is you apply the charges here. Suppose this comb here is connected with the positive terminal of the battery. That means all of the positive charges goes on this comb. Then it becomes positively charged. So in this area, it becomes positively charged. Positively charged. Then what happens? If positive charges are accumulated in this comb, then you start the, positive charges are accumulated. But here in the pulley, you can see here, or in the belt, you can see this part of the belt. It is electrically neutral initially. But when it sees the positive charges nearby it, there are, you see, here is the comb with positive charges, and here is the part of the belt. Initially, it has equal number of the plus and minus charges. But when the electrons on the belt sees the positive charges nearby them, then they attract. That's why they discharge using the air, right? They cancel out. You can see that minus charge comes to the plus charge, minus charge comes to the plus charge, and you see the spark, let's say that, or the discharge, or they cancel out. And then this part of the belt, electrons are removed from here. Then it becomes the positive charge. This part becomes positive. You can see here. So here the positive charges are accumulating. It's like these positive charges are shifted here. This is like, you feel like that. Now you run the motor. These positive charges here start to move because it turns, it rotates. Now it reaches, these positive charges reaches to the top part near that belt, near that next comb. This comb is electrically neutral here. Then it sees the electrons, sees there are some, the electrons see that some positive charges nearby them. Then the negative charges discharge again, right? Because negative charge wants to come nearby this positive charge, and positive charges are repelled and goes to the another side of this comb. Then again, plus and minus charge, they cancel, and this comb becomes positively charged. This comb is connected to this metallic sphere, And since these positive charges are free charge, and then they start to move to the surface of the hollow conductor. Same way, then this belt start to move from here and rotate like this. It reaches here, and then again it is positively charged here. This charge reaches here, and this positive charge neutralize the negative charge here, and it remains the positive charge. Again, positive charge accumulate here. Each turn, and this part of the belt remain neutral, no charge, because the charge neutralized here in this point. And the charge, free charge, positive, depending on the situation. Here are the positive in my case. Positive charges start to accumulate on the surface, and the process continues and go on and on. There's a very high amount of charges that are accumulating on the surface of the metallic surface of the Van de Graaff generator. That's why this instrument is utilized to build up the very high amount of voltage. 5 megavolt, up to 5 megavolt, 20 million volts, 10 to the power something, right? Very high amount of volts can be generated by using this Van de Graaff generator. And for example, now all the charge is accumulating here. For example, if you stand on the ground, insulating ground, you can say there is no contact with the ground through some conductor, and you go nearby it, then your here start to rebel, because it has a positive charge. What kind of charge, right? Then you will see the movement of your hair. So in this way, Van de Graaff generator based on the principle of static electricity. And Van de Graaff generator is a powerful generator, uses in early days for the particle accelerator. It has a particle accelerator to do the experiment about the particle physics, nuclear physics, because we want very high speed of these particles. We smash them to each other to see their interaction, what happens, to create the new particles and to see their behavior. So that's how Van de Graaff generator were used. Nowadays, Van de Graaff generator is being used for the teaching purposes for the students. Thank you very much. Today we discussed about the Van de Graaff generator. If you have any questions in physics 1102, just email me or just visit during my class hour. And next topics we'll be discussing about electric field. This is very important topic. Thank you.